Hello everyone, this is Shilpi Agarwal. I am B.Tech from IIT Delhi and I teach students for JEE Main and Advanced. This video is about the 3 September 2020 JEE Main afternoon session paper, one of the questions. The question is of chemistry and it is on your screen right now. Consider the hypothetical situation where the azimuthal quantum number L takes values 0, 1, 2, 2n plus 1, where n is the principal quantum number. Then the element with the atomic number. Options are there. 8 is the first noble gas, 9 is the first alkali metal, 6 has a 2p valence subshell, and 13 has a half-filled valence subshell. Now you can see, if you are looking at this question for the very first time, you may like to solve it. So you can pause the video here and you can solve it. Okay, now let us come to the solution of this question which I have made. Okay, so what you can see, the question is not extremely difficult. You can see L की वैल्यू नॉर्मली हमारी वेरी करती है 0 से लेके n-1 तक. इन दिस क्वेश्चन L की वैल्यू जो वेरी कर रही है वो 0, 1, 2 to n+1 जा रही है. So for n is equal to 1, L is 0, 1, 2. Automatically the subshells will be 1s, 1p, 1d. For n is equal to 2, L will be 0, 1, 2, 3. So subshells will be 2s, 2p, 2d and 2f. And so on. You can do this for other as well, but we don't have time, such long time in papers. So this is, I hope, enough. Now remember, subshells are filled in increasing order of energy. Subshells को हम बढ़ते हुए energy के order में भरते हैं. Now how do we decide that? We follow the n plus L rule. The one which has higher n plus L has higher energy, and if two subshells have same n plus L, then the one with higher n will have higher energy. These rules are followed in our current periodic table. Generally हमारी periodic table में अभी जो rule follow होता है वो यही follow होता है. Question is not saying anything about them, so as a rule of thumb we follow them. So what do? We have 1s, 1p, 1d, 2s, 2p, 2d, 2f. This is a trick to remember the, to make the n plus L rule valid. Then you cross and you get the order of energy of subshells. So 1s, then 1p, then 2s, then 1d, then 2p. So if you go with our options, the first option is about z is equal to 8. So what will happen to z is equal to 8? That means we have 8 electrons to fill. So 1s2, 1p6, and then this is matching with our noble gas configuration. Then we have z is equal to 9, 1s2, 1p6, 2s1. What is this? 2s1. This is our first alkali metal. And then for z is equal to 6, we will have 1s2, 1p4. So valence subshell is 1p and not 2p. And when z is equal to 13, what will we have? We have 1s2, 1p6, 2s2, 1d3. No half-filled subshell. So the logic that we have used in doing this question is that since nothing is stated, so we follow the general rules, and these are the answers that we are getting. So we are getting 2 correct answers. What are those 2 correct answers? That 8 is our first noble gas and 9 is our first alkali metal. So the problem with this question is there are 2 choices which are correct. But the bigger problem with this question is Not that the two options are correct. That is one problem, but still a bigger problem is NTA is giving the half-filled subshell as the answer, this one. NTA is giving this one as the answer. Let us see how they are not following general rules. They are saying simply apply that energy is increasing in the order of n. Probably 1:1p6 1d5 will be the configuration, and 1, 2, 3 are wrong, and then 1d5 is half filled, so z is equal to 13 is that is the correct configuration according to NTA. Now you tell me, is their logic correct? Okay, you can take a moment here, but I hope you might have an answer by now. Now let us see, can we obtain this answer? Yes, we can obtain this answer if we assume that order of energy of orbital is 1s, 1p, 1d, and then 2s, and so on. But why should we think like this? Why? Out of the box. After all, it is a hypothetical question. In a hypothetical question where nothing is stated and you are simply saying alkali, you are using the general terms alkali, metal, noble gas, that means you are talking about general things. So that will mean that n plus l rule will be followed. But even after answer key challenge, NTA has not changed the answer to this question. NTA has not changed the answer to the question in the corrected answer key as well. They have maintained that 13 will have half-filled valence subshell. Can there be a different underlying thought in it? Yes, probably yes. Consider the hydrogen atom case. Here we have, this is one which we study a lot. So let us consider this only. Energy of 1s is minus 13.6 electron volt. Energy of 2s is minus 3.4 electron volt. So what do you see? That the energy difference between 1s and 2s is very large. There is a 75%, whopping 75% increase in energy from 1s to 2s. So the energy gap between 1s and 2s is the largest one. And as you know from atomic structure that between 2 and 3 it is still smaller, between 3 and 4 it is still smaller, and it keeps on decreasing and reaches a continuum at n is equal to infinity. So such increase is there in all atoms as well. So energy of 1s and 2s के बीच में जो difference है वो सभी atoms में है. Hence there is a possibility that energy of 1d remains less than 2s and not follow the n plus l rule. What do we mean to say is that 1 की एनर्जी इतनी ज़्यादा कम होती है 2 से कि 1d की एनर्जी ऑल्दो 1s और 1p से ज़्यादा होगी, पर क्योंकि वो 1 है इसलिए वो अभी भी 2 वालों से कम ही होगी, which justifies their answer. But an opposing fact is also working. As z increases, जैसे जैसे z बढ़ता है सारे ऑर्बिटल्स की एनर्जी और घटती जाती है. That means energy of 2s is also going to decrease. Hence for z is equal to 13, there is a faint possibility, but there is a possibility that energy of 2s is slightly less than 1d, or energy of 2s is less than 1d. Like, in general what we have is energy of 3d and 4s, energy of 3d and 4s. So energy of 4s is less than energy of 3d in spite of n is equal to 4 being more than 3. This happens. Then the only problem is that this is a hypothetical question. We don't have data for such hypothetical cases, so we cannot be sure. Both things can be true. This can be true as well as this can be true. Where is the data to support? We have thoughts for this as well and this. So what do I have to say? I just want to say this, that no doubt it is a great question, no doubt about that. But it is an open-ended question. It is an open-ended question, good for subjective test, in which student can very easily explain why one is doing whatever one is doing. For objective test, either of the following should have been mentioned. अच्छा क्वेश्चन ये ऑब्जेक्टिव के लिए तब होता है जब ऐसा कुछ मेंशन होगा, जैसे N+L rule is followed. Then obviously option 1 and 2 will be correct. Although 2 options correct, B is not a good idea for a paper with one option correct. Then second what could have been done is that they could have clearly mentioned that energy of n is equal to 1 will be taken as a smaller than energy of n is equal to 2 for any subshell. Or they could have said that energy is a function of n only. Or they could have said choose the incorrect option. Now if they would have said first N+L rule is followed, then option 1 and 2 would be correct. If they would have said E1 is less than E2, then 13 would have option 4 would have been correct. If they would have said energy is a function of n only, then option 4 would be correct. And if they would have said choose incorrect option, then this one 3, 6 has a 2p valence subshell. That would be incorrect anyway. So what should NTA do? Probably NTA should frame not only good questions but also questions with single solution and get their questions checked thoroughly before publishing for the JEE main paper. Thank you for watching.